All right, welcome everybody. We are doing solving systems of equations and we are using substitution. So up until now, we looked at systems of equations that were all linear equations, so straight lines. And now we're going to look at an example that is including here a quadratic equation, okay, or equation of a second power. So we have the system and you can graph it right away to see whether there is intersection or not, whether you're working in vain. So when you look at this, you know that you have to tackle it from the side of this. If you're doing substitution, you're going to work on the linear equation first and get that to be solved for y. Okay, so solving this for y, add 2x to both sides, so you end up with y equals 2x plus 5. Okay, so this is solved for y. Now that you have this, you are going to go and substitute it right in here. Okay, so you solve the second equation, so you can substitute it into the first equation. Over here, we're going to now have x squared, okay, minus, don't forget that you have to distribute the minus to everything, okay? So minus 2x minus 5, all right? And then the rest of the equation, plus 3x minus 1 equals 0. I'm solving this already for 0 because I know that this is a quadratic equation. And in order to solve a quadratic equation, I need to use the zero product. Okay, so we have now, let's clean this up a little bit. This is x squared. Let's combine the plus, the negative 2x and the plus 3x. That's going to be plus x, okay? And negative 5 and negative 1 is negative 6. Now, this is something that is easily factored. So I can think of two numbers right away that are going to multiply to be a 6, okay? A negative 6, in a matter of fact. And they're going to add up to be positive 1. So those numbers are going to be positive 3 and negative 2. Okay? If you need a little bit of a brush up on the factoring, go ahead and do that. But now that I have this, I can very quickly solve and figure out my first one, okay, x1, what in here, what in this set of parentheses would make it multiply to 0? Well, I can plug in here negative 3, okay, or you can solve x plus 3 equals 0 and see very easily that this is negative 3, okay? And then what would make this to be 0 so that the whole product is 0? Well, this is going to be x2 is 2, okay? We are not finished because now we need to figure out how much is going to be the y, because each solution is a point. So a point has an x and a y coordinate. So you take your negative 3, okay, and you plug it in here. 2 times negative 3, that's negative 6. Negative 6 plus 5, that's negative 1. So the corresponding y for this x is going to be negative 1. Okay, so your point is negative 3, negative 1. That's your solution, or one of the solutions. Your second solution was x equals 2. So now I have to go with this 2 and plug it into this equation. 2 times 2, that's 4. 4 plus 5, that's 9. So my y2 is 9, right? So this point over here is 2 comma 9. Graph it, make sure that it works out. Also, don't forget to check your solutions, all right? There are a lot of steps that we can make mistakes in. So take a moment and make sure that this, when you plug it in here, does equal 1. Take this, plug it into the orange equation, make sure that it equals 1. If it doesn't, go see if you can find your mistake.